close this so that people can join and watch me struggle if they want to. So let's put this into the Discord. Minimize Discord. Let's also take this. Boom. Okay. Now I just need to open my second screen and make sure that I open chat there so that I won't miss it. So let me just minimize all of this. Open YouTube. Close other tabs. YouTube. Because for some reason YouTube Studio keeps messing with me, so I won't be able to see chat. So this way I make sure that I have a regular viewer open and I can see chat when it arrives. So let's first go back to day 20. Let me show you. I completed day 20 today. Basically all my code was correct. I just didn't there was something that I didn't do, and that was the way that I walk the area. So I had a sparse mapping of all the on pixels, but since and yeah, you can go back to yesterday's stream. I had all of that code already. I saw what was happening. I could see that, like, if you go to a non-existent space that has no data, it will flicker on and off repeatedly, and that is what happens to the infinite space. The thing is, your square of data, like your field with data, it expands by 2 every time. Because, like, for part 1, well, it never turned out to be part 1. But what I did here was that for every pixel that we had, I would make a big square around it, so -2 in each direction, to make sure that everything that that single pixel influences gets calculated, right? So if you apply that to a map where every data field pulsates, and there is parts where, like, fully 0 and fully 1 toggle each other on and off, so the infinite space, we don't have to account for it, except that every data point in our map that we have data in will expand by 2 pixels, because all the data near the border messes with the on-off stuff, right? So normally it would go on, off and on, but there is data in there that mixes with the infinite stuff that causes there to be irregular pixels around that border. So what I did was, instead of looping through all the pixels and all the pixels that they affect, since basically if there was, let me just draw it. So let's say this is the area where we have pixels, and let's say we have some pixels here, and we have some pixels here, and we have some pixels here. What I did was, I would do this area and just the white space around it. You can treat that as the +2 spacing, but it would never do these parts because there was no reason to, because it didn't change. But with the real input data, something where there is nothing, it will get flipped on and off, right? So what I did was, instead of looking at all the individual pixels, because I thought I would be smart and not do any unneeded coding, what I did now was just, okay, I take the bounds, so the lowest and highest XY, and put 2 around that, and make this just the entire map that I process, right? And every time this grows by 2. So I made a function that's called expand. Let's see. Yeah, I have a function called expand that just tells you how many pixels you want to make your current bounding box bigger. and I use that. So I calculate the initial bounds for all the data points that we have, and after that we just always process that with 2 pixels of padding. And once you run that, it gives you the correct answers. So I didn't have to change any other code other than just the looping. So instead of just processing the sparse mapping that I had, I needed to make sure that I did the that I needed to do the full size. So yeah, so I submitted those and I got my 2 stars. This was a hunch that I had because I wasn't sure that it was going to work, and I was like, okay, I'll try this, and if it works, fine, and otherwise I'll move on and see when I can get back to this. So usually I would do this on stream, but yeah, I just had a few moments today and where I wanted to make sure that it worked. So yeah, let's read day 21 and see if we can do this in one shot today. Dirac dice. Okay, there's not much to do as you slowly descend to the bottom of the ocean. The submarine computer challenges you to a nice game of Dirac dice. This game consists of a single die, 2 pawns, and a game board with a circular track containing 10 spaces marked 1 through 10 clockwise. Okay, so going around you get 1 to 10. Okay, each player's starting space is chosen randomly. Your puzzle input. Player 1 goes first. Okay, so whoever starts is the puzzle input. Okay. Players take turns moving. On each player's turn, the player rolls a die 3 times and adds up the results. Then the player moves their pawn that many times forward around the track. That is, moving clockwise on spaces in order of increasing value, wrapping around to 1 after 10. So, if a player is on space 7 and they roll 2 to 1, they move forward 5 times to spaces 8, 9, 10, 1, and finally stopping on 2. After each player moves, they increase their score by the value of the space their pawn stopped on. Player score starts at 0. So if the first player starts on 7 and rolls a total of 5, they would go stop on space 2 and add 2 to their score for a total score of 2. The game immediately ends as a win for any player whose score reaches at least 1000. Okay, since the first game is a practice game, the submarine opens a compartment labeled deterministic dice, and a 100-sided die falls out. This die always rolls to 1 first, then 2, then 3, and so on up to 100. Okay, we had that kind of thing happen a few times already. After which it starts over at 1 again. Please play using this die. For example, giving the starting position, player 1 starting 4 and 8. This is how the game would go. 1, 2, 3, 4, 5, 6, 7, 8, 9, okay. After many turns, player 2 rolls blah blah blah. Okay, final score down. Since player 1 has at least 1000 points. Oh, was it at least 1000? At least, okay. So once you go on or over, it's gone. That's an interesting one. Like this whole 66766 thing, but that's also based on the mod. Since player has one, okay. Since player 1 has at least 1000 points, player 1 wins and the game ends. At this point, the losing player had 745 points, and the die had been rolled a total of 993 times. 7 times that. Okay, so the loser times the amount of dice rolls. Play a practice game using the deterministic 100-sided die. The moment either player wins, What do you get if you multiply the score of the losing player by the number of times the die was rolled during the game? Okay. That is interesting. Because I already... There's like a formula for this. But I made a dictionary to look up those values, and that was faster. So yeah, I'm probably going with that approach again, just because it worked last time and was faster. Let's see. There are some things that might trick me up here. Trip me up. Okay, so let's see, day 21. Let's remember to set the base date here as well. Okay. Int p1 equals is 4, int p2 equals is 8. So let's do that. So I probably need to go, because if I take 300, because once I get to 999 I have one remaining and then the mod rolls over, so I think I can do mod 300 and have those in there. So let me see. Dictionary int dice lookup is blah. Result is new. Like that. So now we do for int I is 1, I smaller or equal to 300. Let me think, because I want to have this 0 indexed probably. I can go actually to 1, 2, 10. Let me think. Yeah. I plus is 3. Result.add. Result.count, and then we do I plus I times 3 plus 3. Right? So you have 1, 2, 3, so it's I times 3, so 1 times 3 plus 3 is that. So if you add 4, 5, 6, yeah, you get 12 plus 3 is 15. Yeah, okay. So we have 100 in there. Yeah, I think that should work. Except this needs to be mod 100. So this needs to be. Let me think. Because you have the first this goes great until 999. So let's see, that will be 97 times 3 plus 3 is 294. It will work up to there. I'm doing this wrong actually. No. Why am I tripping up on this again? This should be smaller or equal to 100. Let me first run this because I keep return result. Let me just do this and debug it and see if my mind unstacks. Bar test is cool. And I need to actually run day 21, not day 20. Program day 21. So this is one too many, which is to be expected. The thing is, how do you handle that? That's probably the difficulty here as well. So let's see, this one needs to be smaller than 100. Then you get while I really like this, I'm going to do it just a stupid way. What I could do is smaller equal to 300 like this, int val is 1, constant amount is 100. Yes. Why is it complaining here? Probably because I'm running. Okay. So what I can do is result.add. This can just be a list of int. Let's see, int local val is I. Could you live share the code? I don't know. I don't think I have that set up, but you'd mess with me too much. Let's see, if I and then I can just do this again. I mean, this is the stupidest way I know how to do this, but this will work. So let me run this again. Famous last words, because I modified the wrong thing. I need to increment a val here. Not I. I is just the counter here. Okay, so let's run this again. So yeah, these are all the values. Let me see. It's larger than max. Remove that. It's an interesting case. Let me just check this out the first time. So this case val needs to be. It never happens on the first one. Okay. And I need to increment it here one more time, right? So 1.1, yeah, okay. This should be correct now. And now test should have same values. Let me check, quick watch. 6, 15, 25, etc. Yeah. And it should go up to 294, I think, the first time. Okay, so this is a weird one. Ah, no. That would be 99, 20, and 1. Yeah, okay. Yeah, that makes sense. Okay. So let me just test out this whole thing now. So now we can do roll index is 0. Int p1 val is 0. Int p2 val is 0. Player 1 starts, okay. So we do while p1 val larger than 1000 and p2 val smaller than 1000, and then we roll. Okay, so we have that. So constant win score is 1000. Let's put that in here. Like the modulus thing will cost performance, but we also need to have the roll count, so we might as well do that. I could optimize it by keeping 2 indexes for rolling, one like the absolute counter and one that flips over after 999. But let's not optimize too early and see if we can first get the correct result. P1 val, P2 val, rolls. Roll index. Okay. And then we do int roll is rolls plus plus roll index. Oh no, actually we like that. And then we do bool p1 is true if p1, actually we can do p1 question p1 false. Let me just do it like this. Else p1 is not p1. P1 false is p1 false plus volt percent 10. Okay, so like this. Let's see what happens when I run this. I never increase the score, so that is amazing. So we do p1 val plus is p1 plus over here. And yet again, wrong value. Jesus. It's going very smoothly so far. Okay. So this isn't correct, which is nice. Okay, let me see. Console, right line. It's not actually not base 10 is actually fine. What I need to do is if b1 pulse larger than 10, b1 pulse min is 10. So that. Let's run this one more time. Okay, still need to debug this, so let's do that. Dun, 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 dun. Bum, 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 bum. Should probably do like this -1 plus that percent 10 plus 1, which is annoying, but should work. Bum, 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 bum. New boss, p1 val plus new boss. Okay. Don't forget the dice goes to 100. Yeah. Don't I have that? Let me see. I think I have 100 in my die, but let's check. So like my rolls have 100, you see? So that should be good. But I may have done something wrong with this thing. Let's just see. See, score of 10. Okay, so the first part, so far so good, right? Let's also do this here. P2 pause. 2 roll one. P2. P2. Okay. Let's just run. Let me just stop this, run it, and then debug the first few steps to see if it's correct. 10, 3, 14 for a total score of 9. Oh wait, what? Three plus 6, and here it makes 19. What the F? So that is my problem. Ah, I did roll plus. Wait, what? New pos. Actually, that shouldn't be an issue. Let me see this. Ah, right, because this goes many times over. I just need to use this thing. I already have it here, so. So many things that I can mess up here. It's so much fun. This one needs to be removed, and that as well. Okay. How do we end up? Do we get the same? Ooh, 331? Is that correct? No, the dice has been rolled 3 times that amount. Ah yeah, I need to do that times 3, right? Okay, nice. I got it. Okay. So you can remove this. Remove this. I could probably also pre-calculate all the offsets based on which place it starts from, but yeah, let's not get ahead of ourselves. Result. Now we do math.min. Come on, math.min. P1 val, P2 val times roll index times 3. Okay. So that probably needs to be along. And the result will be blah 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 7, 8 something. Okay. So that is correct. Woohoo. So will this whole thing be along now if I do this? I can't even find quick watch. I don't see a quick watch option, but okay. Let's see if that overflows, probably, but yeah, let's see what the input is actually. 7 and 8, okay. P1 pulse is 8, P2 pulse is 7. Okay. Woohoo! Part 1 done. Okay, great. Okay. Continue to part 2. Now that you've warmed up, it's time to play the real game. Sure. The second compartment opens, this time labeled Dirac dice, and out of it falls a single 3-sided die. As you experiment with the die, you feel a little strange. An informational brochure in the compartment explains that this is a quantum die. When you roll it, the splits into multiple copies, one for each possible outcome of the die. In this case, rolling the die always splits the universe into 3 copies. One where the outcome of the roll was 1, one where it was 2, and one where it was 3. Okay, the game is played the same as before, although to prevent things from getting too far out of hand, the game now ends when either player's scores reaches at least 21. Using the same starting positions as the example above, player 1 wins in that many universes while player 2 merely wins in Jesus Christ. Okay. Okay, that's annoying. Using your given starting positions, determine every possible outcome. Find the player that wins in more universes. In how many universes does that player win? Okay, so there must be a trick for this, obviously. Is one divisible by the other, maybe? I mean, these are so many options, so that's not something you can just brute force. Yeah, I don't even have an idea of where to start. I don't think I'm going to even try this because I just don't have an idea of how to do this. Remember the polymers. Yeah, but I don't see it. There we could stop after like the first one. With a given, there was a way to shortcut it, but I don't see, because there are so many variations, because every change has an impact on the number rolled and all of that. So yeah, I really don't see how to code this up. So yeah, I think I'll just end it here because I don't know how to do this. I don't, from the problem set, I really don't know how there's any way to shortcut this, or because due to like the rotational nature, depending on the state of the board, rolling a 1 or a 2 can have a big impact on how much you score. So The only thing is that it works both ways for everybody. So no, it's just not clicking for me. I know there is a way to do this. I'm sure of it, but I don't get it right now, and I don't think that me staring at the screen for a lot longer will help me. So I think I'll probably just watch some videos later, see how somebody else explains it, and then yeah, because I don't see the trick right now. Because I don't know how, I wouldn't even know how to, because I know there's like there are 3 possible options for every given starting point, but that still doesn't I still don't get how that would change things here. Because I like, okay, if there's a clear ratio between these, like if there was something linking these numbers together, it's like, oh yeah, you could do that, but no, I really don't see it, because I think there's too much stuff that influences it, so it doesn't click in my head. So yeah, I'm not going to do this, because even if I check like the possible options for each starting point, I still don't know how that helps me. Because in the end, like, these are the combinations that start, and I know you can reduce this by no, can I even? No, it doesn't click in my head, so this isn't gonna work, I'm afraid. I'll end it here, and maybe if I figure out the trick from somebody else, I'll just code it tomorrow, just for fun. But yeah, I don't think this one will come from my own way of figuring out, I'm afraid. So I'll cut it here, and thank you for keeping me company, Luc. And I know that you finished this one, but it just doesn't click for me here. So yeah, I'll say good night, and maybe join me again tomorrow, as I'll try to struggle less with the challenge. So bye bye.